I'd like to welcome you all to the fourth session in this virtual conference, where the main theme will be focusing on electrical system operation and maintenance. This system always seen to be a very critical infrastructure for any economy. And that's why, and the reason behind this one is for mainly two reasons. Number one, the impact or the severe impact of this system on any economy, as well as the associated risk with this system if not maintained and operated properly. So in this session, we'll be able, inshallah, to review together three presentations from our distinguished speakers. And before starting introducing them, I would like just to remind our speaker that they will have 15 minutes to conduct their presentation. So please try to stick to this timing. And also another announcement to our audience to send their question or any comments on the platform. So we will have, inshallah, at the end of this session, about 15 minutes to go through their question and answer. So we'll proceed now to the first paper. The title is Designing Safe and Reliable Electrical Asset Management Program. Our speaker today, Mr. Martin Robinson, is the Chief Executive Officer of IRIS Group. He has over than 30 years of experience in the field of condition-based maintenance technology. Also, he's an innovator and pioneer for the technological benefits of designing reliable and safe electrical maintenance program. So, Mr. Martin, floor is yours, so you can start your presentation.
Thank you. Presentation where we're going to discuss how to design safe and reliable electrical asset management programs. Where to really start is the first thing I really want you to sort of think about is changing your mindset, because you cannot solve a problem with the same mindset that's created it. So you really want to enter this with a really fresh perspective. Now, if you think about reliability is about many things. You have design, storage, install and start up, operations, and obviously maintenance. Now, every area of this has an element of defects, and each one of these silos will inject a defect into the system. And when you think about reliability is not about maintenance at all. Reliability is primarily about defect elimination. And one thing you can't do with reliability, you can't maintain your way to reliability. You've got to look at design and purchase and storage, etc., and look at how we can remove the defects from each one of these. And that will make us more reliable. Now, I always think you should start with a PMO program, plan maintenance optimization. And when you look at your PMs, I mean, don't assume they're correct. So this is the results of 20,000 PM tasks that were looked at. And basically they found 11% use as is, 8%, 33% could be replaced with some level of PDM or condition monitoring, 26% were re-engineered, 7% were transferred to operation, and 15% were transferred to lubrication. These are significant, very significant. If you think about 33%, yeah, that's 6.5. Together. Also, don't think about your vendor PMs. Don't assume they're same thing that was done with 964 PM tasks for vendors. We found 38% could be used as is, 21% could be, 23% were extended intervals. We found 12% could be done with new tasks, and 6% actually needed to be done more routinely. Because don't forget, your PMs don't look at the operating elements of how you utilize your assets. They just give you a generic umbrella type statement on you should do maintenance or you should do an intervention under such and such circumstances. Now, also this study found that there was 96 new failure modes found during this examination. So look at reliability centered maintenance. Basically, there were 4 main studies completed on reliability centered maintenance. You had the Nolan Heap original studies for commercial aircraft, then the Bromberg study. Then that was followed by 2 major studies by the US Navy on subsurface and surface ships. Now, what we found in those was basically looking at the way things failed. And look, we were looking at time-based curves, and what came out of the original Nolan Heap study and was sort of confirmed with the other studies is the majority of things aren't time-based, okay? The majority of things are actually random. And looking at this curve here, we see the random failure points. And the most important thing is most failures occur in reality. But if you look at the US Navy, when they did their study, the US Navy runs to, or most organizations like that, run a precision maintenance and high condition-based maintenance programs. That basically, if you look at the US Navy's subsurface ships, they got infant mortality down to 6%. Now that does obviously increase the random failures, but okay, by doing unnecessary maintenance or getting rid of the requirement for unnecessary maintenance, they were reducing their infant mortality significantly. Now, the effects of time-based maintenance mortality. This is where I should be doing maintenance is not when the equipment's running effectively. Where I should do maintenance or conduct repairs or an intervention is when we see a state of change. So if I start to see, if you look at the PF curve, etc., the point of potential failure, then that's when the intervention should be occurring or soon after, so I can bring the asset back into an acceptable level. Okay, all the other maintenance I'm doing is unnecessary, costly, and has the ability of actually resetting the infant mortality clock. So we don't want to be doing that. So if you look at planned time directed maintenance, basically that's like saying it wasn't broken, but we fixed it anyway, which is crazy. Crazy. We have to stop the way we look at this. Yeah. Fix things when they're broken or about to break, do your interventions, bring the assets back into an acceptable level. And as I say, if you look at infant mortality, every time we complete unnecessary maintenance, we reset that infant mortality, inject defects, we cause more failures than we fix. So what we're saying is condition-based or condition-driven repair is primarily to ensure we're not over-maintaining our equipment. Yeah. So installation startup, yeah, the greatest risk of defect, failures, etc., is at startup. So how can you minimize that risk? You do less shutdowns. Only do shutdowns when they're required. Yeah, if you look at installation startup criticality, Ron and Hess says you're 7 to 17 times more likely to introduce defects during startup. BP says incidents are 10 times more likely during startup. The chemical industry reported process safety incidents are 5 times more likely during startup. New equipment can have twice the number of infant mortality defects than existing equipment, and 92% of rotating machinery is reported to have defects at startup that result in premature failure. So stop shutting down to do unnecessary maintenance, and you will impact these numbers significantly. So condition-directed repair programs are, if it isn't broken, don't fix it. Yeah, it just doesn't make sense on any level. So a fun fact here, the Mars lunar rover was designed by NASA engineers to last 90 days. How long did it actually last? 14 years, because there was nobody there tinkering with it or messing around with it. It was designed to purpose. Yeah, and then a true NASA sort of style, this thing just went on and on until the batteries could recharge no further. So looking at designing for safety and reliability, how do I get this equipment to be safer? So here we have what I call the KISS principle. You've probably heard of it, keep it simple, stupid. This is not saying you're stupid. What it says is you look at complex scenarios and you simplify them that they can be done easily and routinely. So mistake proofing, or what the Japanese have a great term called poka yoke, mistake proofing. So when we look at mistake proofing using designing for safety and reliability strategies, yeah, to prevent defects in our everyday CBM activities and processes, we can use DFSR, sorry. Errors should not be considered inevitable, and any type of error can be reduced considerably, if not eliminated altogether, using a DFSR strategy. We can create safer work environments. We can ensure consistency of quality results. We can make problems more visible, and we can lower the cost of design and manufacture utilizing DFSR. So these are types of strategies that we use. I mean, a 3-pin plug, make sure you plug it in right. Lockout, tag out is a management strategy to make sure the equipment isn't energized while people are working on it. The McDonald's bun height gauge, make sure that your Big Mac or whatever you're fond of is the same thickness every time, because the perception of quality, if it was too thin, you're not getting what you pay for. The infrared windows maintenance inspection systems, plug-in sensor units, all of these are DFSR strategies. So reducing maintenance-induced and safety failures. And maintenance-induced failure is a significant phenomenon, and it's a significant problem that we have daily. So if we're going to look at the electrical safety ring, this is an overall health and safety curve that shows for every 300 recordable injuries, you can expect 1 fatality in a standard health and safety workplace scenario. Now, if you look at the electrical system, that changes significantly. That means the figures show for every 10 recordable injuries, that equals 1 fatality. So the ratios are frightening. So that basically means it takes only 10,000 electrical at-risk behaviours to have a single fatality. So we have to stop the at-risk behaviours. This is a graph showing the correlation of condition-based work orders with injury rates, and if you can see that the more condition-based maintenance we do, the less injuries we see, because we're just interacting with the equipment in a safe and effective manner. So if we think about managing risk, this is what it's all about. When you're looking at managing your assets, you're managing the risk of failure. Many different ways to calculate risk, and there's lots of organizations have their own specific ways of doing it, but this is a very simple method that I sort of subscribe to, where we look at severity of the problem by probability by detection, and we give each one of those a score from 1 to 10, and then our risk parameter is severity times occurrence times detection. Once we've done that, we take those results and we will plot them on you could have a risk matrix. This is a heat map, but again, there's no one way that's more correct than the others. It's whichever suits your organization. So here I have my risk map. And now I'm going to ask myself a question. What's my risk appetite? How much risk am I prepared to take? An important thing, appetite. The lower your appetite, the higher the cost to maintain that. Yeah, if you have a higher risk appetite, it costs less money to maintain that. So be very much aware that of these points. So once I understand my risk appetite, I can overlay them on my heat map, and here I can come up with an inspection schedule where I might do an annual or semi-annual, quarterly, all the way up to IoT or online monitoring, because there's things that are so hyper important to the organization. So again, severity, as we said, is driven by operations. So there's not a lot I can do there. If something is a risk to life and limit 10, end of story. But I can impact probability and detection by design. If I do more inspections, I can reduce that number because the probability will go down. And if I design a system where I can easily see or detect the problem, that number will go down. Now, what that does to my risk map is it brings everything down to an acceptable risk level. So that's what DFSR is all about. You design the program so you can reduce the impact of the probability and detection. Another area that you might have problems with is skills gaps. Many organizations are really having problems finding the correct skills. This is an article in Forbes, and we can see, and this is US based, but again, these trends are global, where we can see that, if I look at the electrical engineers, 27% are over the age of 55, coming close to retirement. 63% are over the age of 45, and we haven't really trained the engineers coming up behind. So that's why we're using technology far more than we ever did previously. Again, another massive impact. This is looking at total cost of ownership of the asset. Looking at this, you can see, but and again, this was got this from a guy called Ramesh Gulliati, many of you may know. Whilst he was at Jacobs, he did this study, and he's seen, by having a really good design phase for and designing for reliability, it has a significant impact on TCO, up to 40%, and that's a massive number. So designing for reliability at an early stage, again, big paybacks. Another area is your carbon footprint. Increase equipment reliability, reduced time-based maintenance has significant impacts on carbon footprint. You're not buying as many spares, you're not doing as many shutdowns, and the equipment's running far happier and at far cost. So if you look at the, finally, we're looking at the effects of condition directed reliability programs. You're going to have increased safety through hazard removal, to anticipate and plan for repair and intervention tasks, increased time in service, decreased need for intrusive maintenance tasks, a reduced cost of maintenance in terms of manpower expenditure and replacement parts, and reduced collateral damage potential through degradation mediation. And finally, a reduce in your total cost of ownership. I'm a great fan of Deming, and this is one of my favorite sayings: without data, you're just a person with an opinion. It's data that drives our decision, and it should be data that drives our reliability and intervention tasks. So again, thank you very much for attending this presentation, and I think we're going to have time for questions later on.
Thank you so much, Martin, for this very informative presentation. I totally agree with you that optimization now is a very common topic for all utilities. But again, if you don't have, at the end of your presentation, if you don't have a data management system that can really enhance the decision-making process, then you may fail to achieve your target from the optimization. So thanks again for that. Thanks again for your presentation. So now we'll move to the next presentation. The title of this presentation is Optimal Sizing and Location of PV Photovoltaic Distributed Generation and Transmission System using Practical Swarm Optimization. And we have a case study here from Layla town in Saudi Arabia. Our presenter, Mr. Engineer Abdulilah Alsaeedi. Engineer Abdulilah is a transmission engineer in National Grid Saudi Arabia, has 6 years of experience and holding the bachelor degree from in the science of applied electrical engineering at University of Petroleum and Minerals, and he's keen on the control, operation, data management, renewable energy, and also electricity market. So floor is yours, Abdulilah, and you can start your presentation within 15 minutes, please. Thank you.
Today I'll talk about optimal sizing and location of PV distributed generation and transmission system using particle swarm optimization, and it will be tested on Layla town as a case study. First of all, the outline of the presentation. First of all, I will start with introduction. Then I'll move on to the benefits of distributed generation. Later, I will talk about the objective of this study. Then the problem formulation, which will be divided in 2 parts. The first part is particle swarm optimization, and I will emphasize the cause of choosing Layla town network. After that, I will emphasize the execution procedure of this study, and finally, I will show the result and discussion with the conclusion. First of all, originally the electricity was produced by small combined heat power plants in urban areas to meet the demand requirements. However, as the demand increased, it was cheaper to produce electricity in a centralized way in remote areas while investing in transmission and distribution system to meet the demand requirements and serve the consumers. However, distributed generation has become popular lately because it's an alternative approach that could meet the demand requirement and the development also of the grid. What is distributed generation? Basically, distributed generation is a small generation source that is connected closely to the demand. It could be a conventional fuel-based or renewable-based. In this structure, we can see on the left side the conventional structure of grid, where the centralized generation transmitted through the transmission network, then transmitted to the distribution network, where it's served to the residential consumers or the industrial consumers. However, the structure of the distributed generation embedded through the system, it will be changed. It could be the distributed generation connected directly to the distribution network, as we said, or it could be at the households also, such as the PV panels at the rooftop, or also could be at the cogeneration facilities, which be connected directly to the distribution network. What are the benefits of distributed generation? Distributed generation will allow a lot of things. Firstly, regarding the efficiency, when electricity is generated closer to the demand, it will eliminate a lot of power losses lost in the transmission system, which will consume less money in the losses. The second thing is the flexibility. The maintenance and replacement of components of the distributed generation is much easier than centralized generation because it will be fixed or maintained without disrupting the whole system. Third thing, or third impact, is the modularity. The decentralization of distribution energy network means that if one party of the system is break down, the whole system will be disrupted. However, in distributed generation, it will be more flexible and modular to change it or fix it. Fourth element is the economy of distributed generation. Since distributed generation could rely on renewable energy sources, the storage and the renewable energy is becoming more popular lately, and since the cost of and the production and cost of renewable energy is becoming more popular, the prices is continue to fall down, which make it more attractive in an economic point of view. Fifth element is the environmental impact. The distributed generation, if it's renewable based, it has a positive impact because when it comes to the air pollution or the land use. The objective of this study is to focus to reduce the real power losses while improving the voltage profile of the system by optimally integrating distributed generation and the transmission system, where Layla town network is used as a case study. Also, the optimization technique used in this study is particle swarm optimization. Here you can see the objective function formulated in this thesis, where you can see the first objective will be related to the real power losses minimization, and the second objective will be related to the voltage profile improvement, and third objective will be related to the voltage stability index of the network. And the first part, it will be compare the real power losses after integrating distributed generation in the system with respect to the base case without integrating distributed generation. And in the second part, it will be compare the voltage, the general voltage of the system after installing the distributed generation with respect to the voltage of the system without integrating distributed generation. And third part will calculate the voltage stability index of each bus. Then it will take the average of all voltage stability index. The total objective function will target it to minimize this formula. Apart from the technical formulation, there are some constraints they will be considered to decide the optimality of the solution, and it will be as follows. The first constraint is the power flow constraint, where the power of the slack, the real power of the slack or the source, in addition to the power of the distributed generation, should be equal the power losses plus the demand power, which is input equal output. And the same thing occurs to the reactive power. The second constraint is the bus voltage limit, where the voltage of each bus should be between the voltage minimum and voltage maximum, which is considered in this study. The voltage minimum is 0.9 per unit, and the voltage max is 1.1 per unit. The third constraint considered in this study is the output of the distributed generation, which is limited between 0 and 2 megawatt per each unit. Now we'll talk about the particle swarm optimization, which is the optimization technique used in this study. Particle swarm optimization is an algorithm developed by James Kennedy and Russell Eberhardt. It's a robust optimization technique based on the movement of the intelligence of the swarm with social interaction for problem solving. In each iteration, each particle keeps track of their personal best achievement and also the global personal and the global performance of each particle, known as the global best. So each particle will rely on each information, and also the social information, to decide the best performance of each of the whole swarm. The main concept of base particle swarm optimization lies in the essence that each particle in the space is accelerated toward the personal best and the global best location, with a randomized acceleration in each iteration. There are two main formulas dedicated for particle swarm optimization that decide each particle position and the velocity of each particle. Here in the first formula, we can see the updated position of each particle in each iteration, which is equal the initial position plus the new velocity, or the vector velocity of that particle, where the updated velocity rely on two objects: the initial velocity plus the own experience or own knowledge, which is the personal best, and the third element is the social influence, which is rely on the global best or in the whole swarm. Here on this slide, we can see that here is the initial position of the particle X, where it will move toward the velocity, the initial velocity, in that side. Then it will be influenced by the personal best here position of that swarm. So it will go up toward the personal best. Then also it will be influenced by the the global performance of the swarms. So it will go to the right side until the new position is reached. And in each iteration, it will move towards the personal best and the global best until at the end of the loop, it will be close enough to the global best, which will be the optimal solution. Layla Town transmission system was nominated as a case study for several reasons. The first reason, the load of the Layla Town is divided between residential and industrial, which considered as a critical. The second element is the transmission system of the Layla Town is fed from one single substation, which is the substation 8712. So if anything disrupts this substation, it will affect the whole feeding of the network. The third element, it's been noted that at the peak days or the peak time, there are some voltage variation on some buses of the network. Also, the average daily global horizontal radiance in Layla Town is around 6,400 watts per meter square, which has a great potential for installing PV distributed generation. The total load of the system at the peak time is around 100 megawatt and 380 megawatt. And for this study, the execution procedure starts with the values will be optimized, which is in this study is the minimization of power losses and enhancing voltage profile. The second step is running the power flow analysis relying on forward and backward sweep to find the real system power losses and voltage and the bus voltage profile at each bus in the base case without integrating distributed generation.
Layla, you have 2 minutes to conclude your presentation, please.
Okay. So, and this is the parameter used for initialization, the particle swarm optimization. The results had been, the formulation had been tested on IEEE 33 bus radial system, and it's been noted that the real power losses reduced from 176 to 1.103 megawatt, with a reduction around 41%, which is achieved the first objective. And the voltage profile here on the left, it's been noted improved in most of the buses, especially where the distributed generation is installed. For the Layla, the same code have been tested on Layla Town network, and the distributed generation is optimally placed on substation 8761 and 8763 here on this diagram, with a total size of PV distributed generation 3.22 megawatt. And it's been noticed that the real power losses reduced from 206 megawatt to 0.146 megawatt, with a reduction around 29% from the whole system real power losses. Also here we can notice the improvement in voltage profile, especially on the buses where the PV distributed generation is installed, which is the 5 and 7. The conclusion of this study is that optimal sizing and location of PV distributed generation have been tested an IEEE 3-bus radial distribution system, and Layla Town to make the result more realistic. The optimization technique used in this study is particle swarm optimization, and it successfully meet the target. From the result obtained, we noticed that installing distributed generation could minimize the real power losses of the system and enhance voltage profile, which is the target required, which prove that distributed generation is an alternative approach that could be available and more in the future. Thank you all for listening. Off to you, Mr.
Thank you so much, Abdullah. Excellent topic, and I think all utilities now facing this big challenge: how to penetrate this renewable resources without affecting the operation of the whole network. So thank you so much for your presentation. Now we move to the last presentation. The title of this presentation will be Measurement Management System for Reliable Maintenance Program. Our speaker, Engineer Waleed AlFaris. Mr. Waleed is the Director of Business Development in the GCC Electrical Lab, a very promising project for the region. Mr. Waleed holding Bachelor degree of Electrical Engineering from King Fahd University of Petroleum and Minerals. He has more than 20 years of experience in metrology field. Also, he is a member in the Executive Committee of Saudi Quality Council since 2010. A lot of, mashallah, membership of number of committees, and also he is the chair of the Advisory Committee of Gulf Accreditation Center from 2017 to 2019. Also member of the American Society for Quality since 2008. So the floor is yours, Mr. Waleed, and please start your presentation.
Thank you very much, Engineer Waleed, and thank you for the organizer, Arab Council of Operation and Maintenance. Our topic today is about Measurement Management System for Reliable Maintenance Program. If you have the operation team using this kind of meters or measurement equipment, where how much are you reliable and confident of your maintenance program? So trusted measurement implies reliable maintenance. We will go through terminologies, and we will present the measurement management system components, which include management responsibilities and resources management and metrological confirmation and realization of measurement processes. Finally, we'll talk about measurement management system analysis and improvement. So the aim or the goal of maintenance is to maintain or keep the condition and the performance of machine always like the condition and performance of the machine when it is still new. And system is a component of inputs and for work for goal, and which go through certain processes to produce certain outputs, which together accomplish the overall desired goal for the system. And measurement is an action tells us about the property of something. It might tell us how heavy an object is, or how hot, or how long it is. Measurement gives a number to the property. Mr. Russell Dizlet write an article about 5 key components of an effective scale maintenance, and this could be applicable to all measurement equipment. This article was presented in Quality Digest magazine, and he presented an example that if we have a truck which weighs 80,000 pounds, and there is an error in the scale, and this error value is around 200 pounds, which is 0.25%. It is a small error, yes, but this error could generate a loss of around $344,000 annually if we use 500 trucks per day. This is a simple example that the small error in measurement equipment might be translated into many thousands or millions of dollars. And I remember one of my friend, he was the head of a committee who in a factory, and this committee goal is to maintain the measurement equipment and reflect the deviation of or the drift of the measurement equipment into Saudi riyals, and usually they found the impact of this measurement equipment is very high based on the recurrence of the incidents. So calibration is the key component of periodic maintenance, and the right program more than pays for itself. If you have measurement program or measurement system, management system, it pays more than for itself. So this kind of measurement equipment can tell you how is it risky handling the measurement equipment. Calibration can never be guaranteed because accuracy is highly dependent on the way a scale or measurement equipment is used and cared for. So you have to maintain your measurement equipment properly. There are, Russell suggests 5 steps for good measurement equipment maintenance program. First one, use a state licensed service provider. You have to check your service provider. Is he accredited? Is he licensed by the authority or not? Also, you have to conduct calibration using state certified test standards. You have to check also the provider that he used the right standard. And we are very happy in GCC Lab when one of the customers asked about the standards we use. Are they calibrated or not? And he asked a copy of the calibration certificate of our standards. We have to make sure the testing process is thorough, complete, and consider all parameters and impact the measurement process. We have to incorporate visual inspection and repairs for the measurement equipment, and thorough reporting that include all elements needed to ensure that measurement equipment is operating properly. ISO management systems are very different, and we are all aware of ISO 9001 or 14000 for environment or for 35000 for occupational health. But rarely people knows about the ISO 10012, which was published and verified again in 2015, which is a measurement management system requirements for measurement processes and measurement equipment. So manage the risk. The purpose of this standard is to manage the risk that measuring equipment and measurement processes could produce incorrect results affecting the quality of an organization's product or services. So what is measurement management system? It is a set of interrelated or interacting elements necessary to achieve metrological confirmation and continual control of measurement processes. The standard, this is standard, the ISO 10012, start with general requirements for the measurement management system. This include 3 important actions: specify, and identify, and control. Specify scope of application, where you have measurement processes and measuring equipment. Identify risks and consequences of failure to comply with the metrological requirement. And also we need to control measurement processes, metrological confirmation of measuring equipment, the necessary supporting processes also, like, for example, the delivery, shipment, and other and handling the measurement equipment. And the standards start with the first section, which is the management responsibility. So metrological function regarding the administrative and technical responsibilities must be identified, defined through the organization. This is to ensure the resources availability. Also, the management responsibility should focus on the customer, determine and convert, and should be the customer requirements should be determined and converted into metrological requirements, meets the customer's metrological requirements, and the third step to demonstrate compliance to customer specified requirements, and this is demonstrated in the calibration report. Management responsibility includes also the quality objectives for measurement management system to define and must be defined, the objective and established, and the objective must be also measurable. There must be also, as the standard dictates, there must be management review, and this management review should be systematic and to ensure resources. Resource management, we have different resources. We have human resources and we have information resources. For human resources, we need responsibilities of personnel and competence training. For the information resources, we have different elements, procedures, software, records, identification. So procedures must be documented, software must be validated, records shall be controlled, identification of assets, metrological status, authorized use must be documented and declared by the quality system. Also, in the resources, we have material resources and outside suppliers. For material resources, we have measuring equipment and the environment. The environment should be controlled and monitored by traceable equipment, measurement equipment for the environment, like temperature and humidity, for example. Outside supplier, disclose, define, and document the requirements for products and services to be provided by outside suppliers for the measurement management system. So we have to select the right supplier to serve us in the for measurement management system. Metrological confirmation, this include this is to ensure that the metrological characteristics of the measuring equipment satisfy the metrological requirements for the measurement processes. Interval between metrological confirmation should be defined and reviewed, and this is the authority of the customer, of the owner of the equipment. He should identify. It's not the function or the responsibility of the lab to identify the interval. Actually, the standard ISO 17025 said the lab should not recommend the calibration interval. It's based on the usage and the manufacturer specification. Equipment.
Waleed, 2 minutes, please.
Yeah, I keep my stopwatch. So equipment and adjustment seals or safeguards shall be designed and implemented such that tampering will be detected. For metrological confirmation, there is processes should be planned and validated. The measurement processes should be designed based on customer or organization or statutory and regulatory requirements. Realization of measurement processes should be under controlled conditions designed to meet the metrological requirements. Also, the standard recommend to record of measurement processes and maintain the records to demonstrate compliance with the requirements of the measurement processes. Also, in the section of metrological confirmation and realization, which is very important, there is a measurement traceability, uncertainty, and traceability, where all unknown sources of measurement variability shall be documented. The traceability must be the measurement should be traceable to the SI unit, which is the International System of Measurement Unit. Measurement management system analysis and improvement. This is exactly what is required by the ISO 9001, and this is to control that all of the elements of this measurement analysis system are maintained and under control, and there is no deviation, and there is opportunity for improvement. Thank you very much, and this is the end of my speech. By this slide that you have to use your measurement equipment properly, not to use it for different maintenance operations. Thank you very much.
Thank you, Engineer Waleed. Very, interesting topic. And again, the data management system, if you don't have a correct measurement and calibrated measurement also equipment, then the decision-making process will be totally affected by this one. So thanks you again for your very interesting presentation. Now we will go to the last part of our session, which is the question and answer. But before that, I have just small announcement for our audience and attendees that they can really use the meeting hub. Everyone can communicate each other, and also they can also communicate the speaker directly. So the meeting hub can be efficiently utilized to communicate with everyone within this conference. And for the question, I have the first question to Mr. Martin. The question is that, Mr. Martin, where does planned preventive maintenance stand in what you explained about not fixing a device that doesn't need fixing?
It's a great question, but it all boils down to first doing a PM optimization. In the presentation, I sort of discussed that, a lot of PMs are legacy PMs. They come down and they've always been there. So they tend to just go along and get along. Where once you do a PMO or plan maintenance optimization, you look at each of those tasks and see if they're actually required and what have you ever got from those. So by doing that PM, what has been the results? Has it been an effective PM, or is it one of these things that we're just, doing it because it's always been there? So it's all about that. So with regards to reliability, you only repair what needs repairing. So PMs will say tear down, pull down, and all of this, again, as I sort of explained, is all about injecting defects into the system. So the less we interact with the system, the better it is for the system. So always start with the PM optimization, look at the PM, look at its validity, and look at the results, and whether it's worth doing or not. So hopefully that answers that question.
Thank you, Martin. So I'll move to the next question to Abdulilah. Abdulilah, the question here from our audience that what is the basis for determining the size of each distributed PV?
Okay, so as I stated in my presentation that there is upper and lower limit for each bit distributed generation, which is between 0 and 2 megawatt. And in the optimization technique, in each iteration, PV distributed generation is installed in each bus, and the size is increment with 0.01 megawatt. And in each iteration, the real power losses is calculated, and until all trials are conducted. At the end, the trial with the better performance or the higher benefits, it will decide the size of PV distributed generation. With regard to the voltage also improvement in the system.
Perfect, Abdulilah. Thank you. Now to Waleed AlFaris, another question: how your organization manage measurement errors?
Okay. First, we have to send our standard to a higher level laboratory. So we have to maintain our standards, which we use to calibrate our customers' equipment, the UUT. Then, after receiving this standard, we check the deviation from the predefined specifications of the manufacturer, and we calculate this error. And if we can eliminate this error within the calculation, which is the mathematical equation to calculate the result, we can do it. We'll do it. If we cannot, we add the impact of this error into the measurements and certainty budgets we manage in all of the measurements processes we use during calibration the equipment of the customers. I hope this is clear for the question.
Thank you, Waleed. Back again to Martin. What is the standards for medical device safety, especially wheelchair? Do you have any answer for that?
Standard for medical devices, well, it's a quality management system for medical devices, which is ISO 13485. But you know, when it all boils down to, that's part of the ISO 9001. I'm not particularly aware of a specific standard relating to wheelchairs, but when it comes to the reliability practices of manufacturing these devices, your QMS is a good place to start, at least.
Thank you. Back again, Abdulilah, is the use of solar energy financially reasonable and worth the money to control the voltage? And I think this is mainly for voltage control, Abdulilah.
Yeah, I think it's feasible, especially with the prices of PV technologies and operation and maintenance costs going down. I think, yeah, it's economically feasible, but also we cannot see it from one perspective. We should include the other benefits of installing or integrating PV distributed generation system to make the comparison more realistic or fair enough. But in my opinion, yeah, I think it's worth the money.
Good. And maybe also there is another question, that is it financially feasible introducing such a new PV?
Yeah, it's feasible, even though the term payback period might be long. But yeah, at the end or eventually, it's economically feasible.
And I think any project that will pass through technical and economical feasibility study, unless it proves its feasibility, then it will not be
accepted.
Exactly. So I think we have covered the question raised by our attendees. So at the end of this session, I would like to extend my thanks and appreciation to our distinguished speaker for their, amazing participation today. Also, I would like to thank our audience and attendees for their also input to the speakers. And thank you so much for being with us today, and wish you all the best and enjoying the other part of this conference. Thank you so much.
Thank you all.